We are going to be practicing several problems going over rates and ratios today to help get us ready for our test tomorrow. So be sure to have a paper and pencil and do these with me so that you can practice. And if you have any questions, be sure to let me know before you take your test tomorrow. So Antonio was able to drive 237 miles in 3 hours. So I'm hearing that we're comparing miles to hours. So we've got miles and hours. What was his unit rate? Remember, unit equals 1 of miles per hour. So we need to turn this hour into a 1. So I can see that we have 237 miles, and they can do that in 3 hours. Now we want to know the unit rate of miles to 1 hour. So we're going to crisscross multiply here and then divide. So go ahead and try that problem and then come back and check. So 237 times 1 is 237. And that goes inside, and the number by itself always goes on the outside. So 3 can't go into 2, but it can go into 23 7 times, which is 21. 2 left over, bring down my 7. 3 goes into 27 exactly 9 times. So every hour, Antonio was able to drive 79 miles. And after he did that for 3 hours, he made it 237 miles. So I notice my miles was bigger, the hours was smaller, miles bigger, hours smaller. They also went smaller going this way, smaller going this way. Your pattern should always match up no matter which direction you are going. Okay, so let's try this one here. So Cami bought a new pack of hair scrunchies. In the pack, there were 7 plain hair ties and 5 floral hair ties. So we've got 7 plain ones and 5 flowery ones. What is the ratio of floral hair ties to plain hair ties? So I'm hearing it wants floral compared to plain. Let's go ahead and see if you can write that ratio of floral to plain and then come back and check. So since it said floral first, I have to go match it up and find floral, which is 5. And it wants plain second, which is 7. If I wrote this 7 to 5, that is telling me a different problem. That's comparing plain to floral, and it asked for floral first to plain second. So make sure you follow and read along and really pay attention to what the question is asking you. You could have also said that it was 5 to 7 or 5 over 7. So 3 different ways to write that same problem. So now the next part asks the ratio of plain hair ties to the total hair ties in the package. So pause the video and see if you can answer that question. So plain is 7, and then it wants total. So I know I have 7 plain ones and 5 floral ones together. That makes 12. So my total is 12, 7 to 12. So I could also write it with the word to or as a fraction, and those all mean the same thing. So be sure to pay attention to what the question is asking. What does it say first compared to what is second, and put them in that order. A painter was able to paint 30 square feet of a house in 12 minutes. So we're comparing feet and minutes. So here's my feet, here's my minutes. I always want to start with these labels to make sure I get everything lined up. So we know we have 30 feet, and they do that in 12 minutes. At that same rate, how long will it take him to paint 85 square feet? So I want you to think about, where is 85 square feet going to go? Is it going to go on the top or the bottom? So think about, where are the feet? So try that. Okay, so since it says 85 square feet, feet are on the top. So I want to put 85 here on the top. And then I'm looking for how long. I'm looking for the minutes to paint 85 square feet. So we're going to find our crisscross here and multiply. And then we're going to divide by 30. So pause the video and try that out. I promise you practicing these is going to help you. So don't just watch me do it. Make sure you're doing it too. So we're going to start with 85 times 12. So here's 10, 16 plus 1 is 17, placeholder, 5 and 8. So 0, 12, and 10 here. So we've got 1020, and our crisscross number always goes inside. The number by itself always goes on the outside, big or small. So 30 can't go into 1, and it can't go into 10, but it can go into 102. It's like counting by threes. So 3, 6, 9, 12, but we're just going to add a 0 on all of these. So we've got 30, 60, 90, 120 is too big, so it goes in there 3 times, which is 90. And then we've got 12 left over. Bring down my 0, 120. Looks like it goes in there perfectly 4 times. So it is going to take 34 minutes to paint 85 square feet. Hey, this table shows the number of cats and dogs in different neighborhoods. I'm sorry, there should be an S right there. In different neighborhoods. Which 2 neighborhoods have the same ratio of cats to dogs? So we're looking for 2 neighborhoods with equal ratios. So I'm going to start with this Riverbend, and we've got 6 to 7. So now we're comparing 5 and 6. So is there a way to get from 6 to 5 and do the same, and divide or multiply and do the same thing to get from 7 to 6? So think about that. So what could you times or divide to get to these same numbers? And you have to do the same thing on both sides. So now let's think, is there a way to get from 6 to 12? Yes, I would times by 2. Is there a way? So then I'd have to do the same thing over here. And 7 times 2 is 14, and this says 15. So I know Ridge Hills and Riverbend are not equivalent. So I want you to pause the video and see if you can find the 2 neighborhoods that are equivalent, that do the same thing to get from cats and the same thing to get to dogs on both sides. So I'm going to try this next one here. So cats in Riverbend to Mountain Sky, 6 to 18 is times by 3. So 7 times 3 should be 21, and these match up when I times them all by the same thing, times by 3, times by 3, or I can divide by 3, divide by 3. So Riverbend and Mountain Sky are the same. So if I went through Riverbend and they didn't match up, then I could try Desert Bluff and see if anything matched Desert Bluff. And then I could see if Ridge Hills match Mountain Sky. So just go through each and match them up and see which ones are doing the same thing on both sides. Okay, so we have 6 blue Legos and 18 red Legos in a bag. What is the ratio of red first to total Legos? Choose all that apply. So let's just start and write down what we know. So will you just write down the ratio of red to total? So I can see there are 18 red. And when I put the red and blue together, 6 plus 18, I get 24. So this is our ratio that we're given in the problem, 18 to 24. So I can see this one here is the same. So now we're looking for any other equivalent ratios. So 18 to 6. Well, I know my last number has to be 24 if the first one is 18. So this ratio was telling me red to blue, and that's not what the question asked. Hey, we've got 3 and 4 here. So let's think of a number that can be a factor of 18 and 24. So what can go into 18 and 24? 6 goes into both of those. So 18 divided by 6 is 3. And 24 divided by 6 is 4. So since we did the same thing to both sides, 3 to 4 is another equivalent one. Okay, so I want you to see if you can go through the rest of these and find the other equivalent ones and then come back and check. Okay, so 3 to 5. So I know I divided by 6 to get to 3, but 24 divided by 6 is not 5. So that one doesn't work. We've got 6 and 18 here. So remember, we're always coming back to what we know. So how do I get from 18 to 6? Well, I would divide by 3, but 24 divided by 3 is 8. So this would need to be 8, not 18. So 18 doesn't work there. 24 to 18, but I need 18 to 24. If I flip this around, that told me total to red, and that is not what the question asked. So it makes a difference what order they go in. 6 and 8, well, I just proved right here, 18 divided by 3 is 6, 24 divided by 3 is 8. So 6/8 does the same thing on both sides. We've got 1 and 3. So let's see. How do I get from 18 to 1? Well, I would divide by 18. 18 divided by 18 is 1, but 24 divided by 18 is not 3. 24 divided by 8 would be 3. So this is divided by 18. This side's divided by 8. Those are not the same. So, and then we've got 24 and 32 here. So there is not just a way to get from 18 to 24. This one's a little trickier. So let's come back to this basic ratio of 3 to 4, this simplified problem. And if I go 3 to 24, that was times by 8. And 4 times 8 is 32. So this actually is the same ratio. We just can't get there using 18 and 24 as easily. But if I use this basic ratio, if I have 3 to 4, if I keep going, 6 and 8, and then we'd have 9 and 12. So on this side, I'm counting by 3s. On this total side, I'm counting by 4s. So this is telling us every 3 out of 4 total pieces, 3 of them will be red. We'd have 1 more of blue for a total of 4. So 3, 6, 9. I'm just going to count by 3. So 3, 6, 9, 12, 15, 18, 21, 24. I'll go 1 more, 27. Then here we've got 4, 8, 12, 16, 20, 24, 28, 32, and 36. So here's another way we can check is we can take our ratio and simplify it as far as we can go to its basic ratio. Then I can list all of the ratios. If I'm skip counting, that would match. So let's double check ourselves. Here's 3/4, 6/8, 24 32nds, and 18 to 24. So I don't see 1 to 3, 6 to not 18, 24, nope, that should be 32, 3, nope, this should be 4. And if I have 18, then the answer should be 24. So we found all 4. So there's several ways you can just go through each one and check, but watch for those tricky ones that are going to come from the basic ratio here. Or we can just find that basic ratio. So we knew we had 18 red and 24 total. We know 6 is the biggest factor that goes into both of those. So it's simplified to 3/4. And then we can make our list from there. And if it's not on our list, it's not one of the answers. So pay attention to these problems that ask for all of the choices there. Hey, a gardener plants an equivalent amount of trees and bushes at each park. Complete the table to show how many trees and bushes each park has. So remember, our park has equivalent trees and bushes. So we know at every park they're going to have a ratio of 12 trees to 8 bushes. So that doesn't mean they all have exactly that. It just means they have that equivalent ratio. So I can see here to go from 12 to 24, we would times by 2. So go ahead and do the same thing here. So 8 times 2 is 16. So that was easy for that one, but I'm noticing this one, there's not a nice way to go from 8 to 12. So I'm thinking we need to simplify 12 and 8. So think of a number that goes into both of these. So 4 goes into both 12 and 8. 12 divided by 4 is 3. And 8 divided by 4 is 2. So our basic ratio that the gardener is using is every time he plants 3 trees, he'll plant 2 bushes. So now let's think, how did I get from 2 to 12? Well, we times by 6. So we'll do the same thing here. 3 times 6 is 18. So it doesn't matter which one you go from, but it matters that you do the same one on both of them. So to go from Evergreen to Sandy Hills, we did Evergreen to Sandy Hills on the other side. To get Trails Central, we use the basic ratio on both sides. So you just want to make sure that if I use this 2 and times by 6, that I don't all of a sudden do 12 times 6. That will give me a different problem if I'm comparing the basic one to Evergreen. So, I'm missing one here in Rambling River. I'll have to add a number there. So let's say that this is 30 here. So how do we get from 3 to 30? Well, we times by 10. So 2 times 10 is 20. Okay, so we just follow the same thing on both sides from the same row. Hey, Tara read 42 pages in 30 minutes. So we're comparing pages to minutes. And it wants to know the unit rate. So that means one of the numbers has to equal 1 of pages per minute. And since minute came second per minute, we need to turn minutes into 1. So we have 42 pages and 30 minutes. So I want you to pause and see if you can set up the other part of the problem. So we want to find 1 minute. So minutes is on the bottom. So I put 1 on the bottom. And I'm looking for the pages. So we're going to crisscross multiply and divide. So let's go ahead and see if you can do that problem there. So I know 42 times 1 is 42. And we're dividing by 30. So 30 can't go into 4, but it can go into 42 one time, which is 30. And we're going to have a remainder, but we don't want remainders in these problems that are using ratios. We want decimals instead. So I have 12 left here, and I'm adding my decimal. It doesn't change the number. It's still 42. Bring my decimal up and my 0 down. So if I'm counting by 30, 60, 90, 120, that goes in there 4 times. So after 1 minute, Tara read 1.4 pages. So almost 1.5 pages every minute. Hey, this graph shows the ratio of mystery books to fantasy books. So here's our X and our Y. We always go over, then up. That Rachel reads. If she read 5 mystery books, how many fantasy books would she read? So I'm noticing this is counting by 2s. So my 5 is going to be in the middle here. So if I'm going up 5, it's kind of hard to see exactly where this should go. I mean, I know it's going to be here somewhere, but it's maybe a little harder to tell. So let's look for one we do know. So I know when she reads 4 mystery. So we're going to compare mystery and fantasy. So when she reads 4 mystery, 1, 2, 3, 4, she reads 6 fantasy. 4 mystery, 6 fantasy puts us right here on this dot. But I want to know when she reads 5 mysteries, how many fantasies that is. So we're going to come here and crisscross multiply and divide by 4. Let's go ahead and try that problem. So 6 times 5 is 30, and we're dividing by 4. So 4 goes into 37. Yep, that's 28. So 4 times 7 is 28. Subtract is 2. Add my 0 because we want decimals when we're talking about ratios. And then 4 goes into 25 times. So yeah, it would have been really hard for me to know in 5 that this number was going to be 7.5. I probably would have assumed it was just 7, and that's not the correct answer. So when she reads 5 mystery books, she's read 7.5 fantasy books. So make sure we find something we know and set the ratio up, just in case they're not nice, even numbers. Hey, Angelo can complete 6 math problems in 14 minutes. So we're comparing the problems to the minutes. At that same rate, so our rate is 6 problems in 14 minutes. At that same rate, how many problems will he complete in 27 minutes? So see if you can finish setting up the problem. So 27 minutes. Minutes goes on the bottom, so I want 27 on the bottom, and we're looking for the problems. So we're going to crisscross multiply here and then divide by 14. So go ahead and pause the video and try that out. So 27 times 6 there's 42, 12, 13, 14, 15, 16. So now I'm dividing 162 by 14. So it can't go into 1, but it can go into 16 one time. So 1 times 14 is 14. And there's 2 left over. Bring down my 2. 14 goes into 22 one time. 1 times 11 or 14 is 14. So we're going to borrow here. 12 minus 14 is 8. And we need to bring down our 0 here. So I'm going to make a list of 14s. Actually, I'm going to just try 14 times 5 and see where that puts me. So 4 times 5 is 20. There's 5, 6, 7. So it looks like about 5 times. 5 times 14 is 70. With 10 left over. So I know it's got to be more than 5 times. Let's try 8 times here. There's 32. 8, 9, 10, 11 is too big. So 7. So once we have 2 decimal places, we can stop there. So they can complete about 11 and a half problems in 27 minutes. Okay. So remember, we always want to use decimals when we're talking about ratios. We don't want fractions over fractions. Decimals are better to use. So add your decimal if you get to the end and just keep adding zeros. So if it's just going to keep on going, 2 decimal places is a good place to stop. Hey, Ryder bought 11 boxes of crumble cookies for a party. This is my kind of guy here. So his total was $178.75. What was the cost of cookies per box? So I want to know how much one box was. So we know we've got our money and our boxes. So see if you can set this problem up and then come back and check with me. So I know he spent $178.75 and he bought 11 boxes. Now I want to know the cost of one box. So I'm looking how much money was one box. So we'll crisscross multiply here and then divide by 11. So go ahead and try that problem. So we've got 178.75. I'm going to bring my decimal up, dividing by 11. So 11 can't go into 1. It goes in here 1 time. 6 left over. Bring down my 8. So 11 goes into 68 6 times, which is 66. 2 left over. Bring down my 7. Goes in there 2 times, which is 22. We've got 5 left over. Bring down my other 5. 11 goes into 55 5 times. So every box of cookies cost him $16.25. So that makes sense. When I buy 11, I should be paying more than this. So that's a good way to check is, does this make sense? So we got smaller, 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 smaller. Everything should be matched up. Hey, Marcus bought 25 pencils for $8.25. How much did each pencil cost? So how much did one pencil cost? So here's our money. Here's my pencils. So see if you can set up this ratio. So money on the top, pencils on the bottom, and then I want to know the cost of one pencil. So we're going to crisscross multiply and then divide. So 825 times 1 is 825, and we're dividing by 25. So it can't go into 8. I'm going to bring my decimal up, but it can go in here 3 times, which is 75. 75. And I'm going to borrow. So 12 minus 5 is 7. Bring down the 5, and it goes into 75 3 times. So every pencil cost 33 cents. And when I bought 25 of them, I spent $8.25. So now if he bought 32 pencils at that same rate, how much would he spend? So see if you can finish that problem. So he wants 32 pencils now, and every pencil costs 33 cents. So I'm doing that same thing. I'm buying 32 pencils, so I'm getting 33, doing that 33 times. So 3 times 2 is 6. 3 times 3 is 9. I need a placeholder. Ooh, that was really big. 6 or 9 there got carried away. And 3 times 2 is 6. 3 times 3 is 9. And I add these up. I get 6, 15, and 10. But now I need 2 decimals, 1, 2. So he would spend $10.56 to get 32 pencils. And that answer sounds reasonable, a couple dollars more than 25 pencils. So it makes sense that more pencils cost more money. Hey, we've got juice on sale here. Complete the table to show how much different amounts of juice would be at the same sale rate. So all of these should be equivalent. So I notice here 3 to 6 is times by 2. So I want to times by 2 here. That will give me this number. So since these numbers on the top are nice whole numbers, I'm going to skip over here. 3 times to get to 12 is times by 4. So I want to do the same thing here, times by 4. So let's go ahead and do those and then come back and check. So we've got 675 times 2. And so there's 10, 14, 15, 12, 13, and 2 decimal places. So here we've got 1350. And then we've got 675 times 4. So here's 20, 28, 29, 30. That's a 0, 2. Sorry, I'm having a hard time writing with my mouse right now. And then 4 times 6 is 24, 25, 26, 27. And 2 decimal places. So this one is $27. So it looks like the bottom is also following a pattern. I'm getting 675 more, 675 more, 675 more, 675 more. So each time it just is getting 6 or 3 more bottles. So 3, 6, 9, 12, 15. So this is adding 675 each time. This is adding 3 more bottles each time. So now it wants to know the unit rate of price per bottle. So I want to know the price per bottle. So the unit rate is 1. So we want to make bottle 1. So I know if I spend $6.75, that's going to give me 3 bottles of juice. I want to know the price of 1 bottle. So we'll crisscross multiply here and divide by 3. So go ahead and try that problem to see how much 1 bottle cost. So 675 divided by 3 goes in there 2 times. And again, that goes in there 2 times, which is 6. And it goes in there 5 times. So each bottle costs $2.25. 2 times 3 is 6, so that sounds right. 2 times 6 is 12, but it's got the change on it, so that sounds right. So these all sound reasonable. 2 times 9 is 18, that's close. 2 times 12 is 24, that's close. 2 times 15 is 30, that's close. So just another way to check if your answers sound reasonable. Okay, we're going to do 2 more challenge problems. So this table shows the ratio of green to orange marbles that Ricky owns at the same rate to complete the table. So on this last table it was counting just the same pattern, 3, 6, 9, 12, 15. This here is not counting by anything in particular. So we're going to have to figure out how can we get from here to here. So let's start and simplify and see if that will help us get where we need to go. So I'm noticing this is 18 and 27. So can you think of a number that goes into 18 and 27? Well, 9 goes into both of those. So 9, they both have zeros on them. So 180, we're going to divide these both by 90. So 90 plus 90 is 180. So every time they have 2 green marbles, they have 90 goes in here, 90, 180, 270 goes in there 3 times. So every time they have 2 green marbles, they have 3 orange marbles. So now we should be able to use this information to get to the rest of these numbers. So ask yourself, how do we get from 2 to 208? And you'll do the same thing on the other side. So I can see 2 goes into 2 1 time, and into 0 0 times, and into 8 4 times. So to get this one, I would do 104 times by 3. So now we're looking for the green. So we're going to see, how do we get from orange, 3 orange, to 258 orange? So we would have to take 258, divide it by 3, and whatever that answer is, we're going to do the same thing on the other side. And then you would repeat. How do you get from 3 to 351? Well, you divide to see what we multiplied by, and then do the same thing to the other side. So if you want to finish that, you are welcome to. There will be a challenge problem similar to this tomorrow, so it might be a good idea to practice that. Okay, last one here. Anaya ran for 4 days, but ran the same distance per hour each day. So every day she was running the same distance per hour. Complete this chart to show how many miles or hours she ran. So here I can see is where my chart is complete. So I want to use this information to help me get finished here. So I'm going to start though and find out how much she did each hour. So miles and hours. So I know she did 9 miles in 1.5 hours, but I want to know how many miles she did in 1 hour. So 9 times 1, and then we're going to divide by 1.5. So we're going to move that decimal, move that decimal. So 15, so let's see, 15, 30, 45, 60, 75, and 90. Oh, perfect. It goes in there 1, 2, 3, 4, 5, 6 times. So it looks like she is running exactly 6 miles every hour. So every time she runs 6 miles, it's been 1 hour. So this might help us get to these questions a little easier. So we're just going to start looking for things we know. So I notice I can get from 1 to 3.5 by timesing by 3.5. So I would do the same thing on the top and the bottom. I notice that I can get from 9 to 4.5 by dividing by 2. So I'm going to divide this by 2 to get here. So looking here, I don't see really an easy way to get from 6 to 11.5, and I don't know what this one is here. And there's not a nice way to get from 9 to 11.5. So I can set up a new problem though. So I know when I go 6 miles that it's been 1 hour. And I want to know if I go 11.5, how many hours is that? So we're looking for this one here. So you can just set up different ratios for each part. So we'd crisscross multiply and divide, and that will tell me how many hours. So you're just looking for different ways you can get from one to the other, and then do the same thing on the top or the bottom. So this one does not count nicely. 4.5 doubled is 9, but then this isn't 4.5 more. So you've got to pay attention to, is the chart showing you the constant growth, or is it just showing you different random ones using the same ratio? Okay, so go ahead and make sure you do your review on Ed just to do a few more practice problems on your own. And if you have any questions before the test tomorrow, make sure to let me know what I can do to help you.